All right, guys, gonna make a video of your practice test because you said you'd watch it. So here we go. Number one. Um, First of all, whenever you have an e in an equation, you need to isolate it by itself. So I'm gonna move the 7 to the other side first. Make it a 2. Divide by 3 so I can completely isolate it. And once you get here, you got the e by itself. To get rid of the e, you need to do natural log of each side. So I'm gonna do natural log of this side, natural log of the right side. Over here, obviously we're just gonna get x, and you know why. On the right hand side, I'm just gonna punch in natural log 2/3 on my calculator, which I'm doing right now. And I'm gonna get negative 0.4055. That's all you gotta do on that one. Number two. Number two is what we did the first day of the week. We're just gonna find the same base. Since I have 25 and 1/5, the common base is 5. 25, of course, is 5 squared. Lost it there. 25 is 5 squared to the x minus 4. 1/5 is really 5 to the negative 1 power. Remember, negative exponent flips things. And so when you raise a power to a power, you multiply the exponents right there. That's the step I worry about the most. Don't forget you multiply the exponents. Multiply both of them. Once you get the bases the same, you can forget the bases. Just set the exponents equal to each other. And move the 2x over there, make it 1x. Move the 1 over there, make it negative 9. And there you go. That's all there is to it. Let's go to 3. 3 has 2 logs added together. Remember, you can add logs. So when you see log addition, that means you're really multiplying them. So I'm going to do x plus 2 times x, which is really x squared plus 2x. And I have the 3. Now, because you have one log, only one log, I'm going to do this. I'm going to take the 2, raise it to the third power, and it equals this. 2 cubed is that. 2 cubed is that. So that's what I'm about to do right here. 2 cubed is 8 equals x squared plus 2x. And that takes the log away. Okay, we didn't drop it. We actually just worked it out. So move the 8 over. X squared plus 2x minus 8. I didn't leave much room right here. Factor that. Factors of negative 8 would be positive 4 and negative 2. That will give me a positive 2 in the middle. We can read that. So my two answers are negative 4 and 2. Now, the directions up top said check for extraneous solutions. Negative 4 would make that log become negative, so negative 4 can't work. I'm plugging 2 in there. 2 looks good, so 2 is fine. Let's go to 4. 4 may be the easiest one of the first 4. When you have one log on each side of your equation, you're allowed to just cancel, just drop those logs out. So that leaves you 2 minus x here, a 5x there. Move that x over, that's 6x. Divide both sides by 6. You get 2/6, which is really 1/3. Double check it. 2 minus 1/3, that's positive. 5 times 1/3, that's positive. So that's a good answer. All right. 5 and 6, what we worked on yesterday, you need to see that equation. Remember, your job is to find, you're trying to figure out what what A and B are. So we're going to use these points. We're going to plug them in because they work. Put the 3 in for the Y, put the 1 in for the X, and then solve it for A. So I get this, 3 equals 1, A equals 3 over 1B, easy for me to say, 1 to the B power. Then use the second point, do the same thing. So 24 in for the Y, 2 in for the X to the B power. Now to solve that, I'm going to take this A that I found over here and plug it in to the other side. So I'm putting 3 over 1 to the B times 2 to the B. Now, because the 1 and the 2 have the same exponent, you're allowed to divide those and just keep your exponents. So 2 divided by 1 is 2. So that's really 2 to the B times 3. So I'm dividing both sides by 3 right there, and I get 8. Now, you can do log both sides right there if you want to, but what I noticed is I can find the same base. Like 8 is really 2 to the third power, which means B is 3. So there's my B. To find my A, I'm going to take that B and plug it right back where I started. So A is going to be 3 over 1 to the third power. 1 cubed is just 1, so that means A is also 3. So my answer to that one, the equation is going to look like this. Y equals A is 3, X, B is 3 to the third power. So there it is. There's number 5. Right? Number 6 is the exact same kind of problem, just different points. So take your first set, plug them in. 4 equals, what was the equation again? Remember, is this power? Yeah, it was AX to the B. So it's going to be A 3 to the B power. So that means A equals 4 over 3 to the B. Take the second point, do the same thing. Plug the 12 in for the Y, the 6 in for the X, 6 to the B. Take your a over here, plug it in over there. So I get 4 over 3 to the b times 6 to the b. Now, because 6 and 3 both have b's, you're allowed to divide those. 6 divided by 3 is 2, so that's 2 to the b. Divide both sides by 4, you get 3 there. This time I can't find the same base, so I'm going to do log both sides. So I'm doing log 3. Remember the exponent goes in the front. B times log 2. Take your calculator. I'm going to divide log 3 divided by log 2. And I get 1. So my b is 1.585. I'm going to plug that in up here to find my a. So I'm really plugging it right here. 4 over 3 to the 1.585 power. And that's going to tell me what my a is. So I'm going to punch that in too. 4 divided by 3 to the 1.585 power. I got 0.70. So my answer, y equals a 0.70 times x to the b power, which is 1.585 is the power. Not very good handwriting right there, but there you have it. 5 and 6. Let's go to 7 and 8. 7, they give you some great points here for 7 and 8, mainly because of the 0. This 0 in 7 and 8 is going to make your life pretty, well, a lot easier. Using this function this time, the exponential function, so I put the 5 in for the y, a, b, and the 0 for the x. Now the beauty of that 0 is anything to the 0 power is 1. So that b to the 0 is really 1a, which means a is 5. Like a is 5. So take your second point, plug it in. 20 over 9 equals a times b squared. Now, one thing I know a is 5. So I'm going to plug the 5 in there for the a. And I'm going to divide both sides by 5. When you divide a fraction by 5, you just divide the top by 5. So make it 4/9. And that's square. That's b squared is 4/9. So I'm going to take the square root of both sides. So my b, the square root of 4 is 2. The square root of 9 is 3. So there's my a. There's my b. So my equation is just y equals 5 times 2/3 to the x power. By the way, you can check these. I forgot to mention in the last step. You can take the 2 and plug it in for the x and see if you get 29ths. You know, you can always check it on your calculator that way. One more of these. Number 8. Same deal. A 0 again makes life so nice. Put the 4 in for the y, the 0 for the b, for the x. B to the 0 is 1, which means a is 4. Take the second point, do the same thing. 12 is a times b to the 6th power. I know a is 4, so I'm plugging it in. 4 times b to the 6th power. Divide both sides by 4, which is 3. And I'm taking the 6th root of 3 on my calculator. So I'm hitting number 6, going to math, choosing number 5, 6th root of 3, and I'll just get 1.2. So there's my a, there's my b. So my equation is 4 times 1.2 to the x power. All there is to it. Okay. Number 9, calculate your two formulas from last week. The first one says, it says you deposit $200 in an account that pays 2% annual interest. How long will it take for the balance to double for each given frequency of compounding? Monthly is 12 times a year. And this is the formula we used last week. I'm using it again today. Right there to the nt power. Now, just start plugging stuff in. 200 is what you start with. You have 1 plus the, I forgot the 1. You have 1 plus the rate, which is 0.02 over n. N is how many times a year. This time it's monthly, so I'm putting 12. Your exponent is n times t. N is 12. T we don't know. It's asking us how long. Don't know. So I'm putting 12t. This is for it to double. If 200 doubles, you end up with 400. So I'm putting the 400 over there for the final part. Trying to get the exponent by itself here somehow. So first thing I'm going to do is I'm going to take this 200. I'm going to divide both sides by 200. 400 divided by 200 is 2. And that leaves me this parentheses. Okay, and I got the 12t. Now, my advice here is work out what's in the parentheses. I'm punching in 1 plus, open the parentheses for the fraction, 0.02 divided by 12, close. And my inside of my parentheses is 1.002, right? To the 12t power. All right, now because I can't find the same base between 2 and 1.002, I'm going to do log both sides. So I'm going to do log 2 equals, remember the exponent goes in the front, 12t log 1.002. So I'm trying to get the t. I'm going to have to divide twice here. First thing I'm going to do is I'm going to divide by the log. This one's pretty long, actually. Log 1.002. Okay, so what that leaves me with is a 12t over there. That's important. Now there's something I'm dividing log 2 on my calculator divided by log 1.002. I just pressed it wrong. Log 2, sorry about that. Live video here. Log 1.002. Enter. I got this. I got 346.9. And then I can divide that by 12 to get my final answer. So I'm doing that divided by 12. And I'm getting 28.9 years, which is a long time. Pretty much double. But that's the first one. That's the longer of the two. Pretty good problem there. Part B, continuously you're using the PERT formula, P-E to the RT power. Same stuff. You end up with $400. You started with $200, so that's the same. E is E, R is the rate, which is 0.02, times T is per time. Working it the same way. I'm going to divide both sides by 200 because I'm trying to get the E by itself. 400 divided by 200 is 2 again, and I have this. Now because I have an E and I need to go away, I'm going to do a natural log of both sides. Natural log there. The exponent goes in the front here. Natural log E. You know that's just gone. So I have 0.02t equals, punch in natural log 2, and you get 0.693. So I'm dividing that by 0.02, and I'm getting 34.7 years. It takes a little longer that way for it to double. All right, hopefully that makes some sense. That's all this week's stuff. I'm about to turn the page and we'll go to review stuff. All right, number 10, the graph. Please don't make this that hard. It's really not. Log graphs have asymptotes. Usually, when I do a log graph, the y-axis is the asymptote. But because it's been shifted left 2, I'm going to draw the asymptote left 2. Just like this. Very good. My point is I'd usually put my point right here. I'd go 1 away right there and put my point right there. But because it has a +1, I'm going to go over to the 1, but also going up 1 right there. So my first point is over 1 and up 1 from the asymptote. Your second point, this is the challenge. Your second point, I want my parentheses in that problem to equal whatever the base is. Okay, the base is 3. I want the parentheses to be 3, which means I'm plugging in a 1 for x. So don't forget, x is 1. I'm plugging in 1 for x. When I do that, this is what it looks like. I get log 3 plus 1. Log base 3 of 3 is 1, and 1 plus 1 is 2. So basically what happened is I plugged in 1, and I got 2, because that's 1, and that's 1. 1 plus 1 is 2. So go to 1, 2, right there. Then you're ready to draw your graph. It's like that. Your domain, the whole graph is to the right of the 2, so I'm just going to write it this way. X is greater than, negative 2. It's greater than negative 2. The range is going up and down forever. So I'm going to put that. The asymptote goes through 2 on the x-axis, so you need to put x equals 2. Make sure you put x equals with your asymptote. Horizontal translation means how do we shift it left or right? We went left 2. Vertical translation means how far do we shift it up or down? We went up 1 because of the 1 at the end of the problem. And that's it. That's all you got to do on that one. Looks worse than it is. Hope you go ahead and do that one. As bad as that one is, though, number 11 is that easy because it's just asking you how you do a log. Remember, you take the base right here, that 2, raise it to the 4th power, and it equals 16. 2 to the 4th equals 16. And that's all you write. 2 to the 4th equals 16. That easy. All right, number 12. 12 says expand the log. First thing I see in there is I see subtraction. Division, which means I'm going to do subtraction. So I'm doing 1 divided by, notice I did subtraction, 2x squared. Sometimes you might be done right there, but this time my second one right here has a multiplication in it. So what I'm going to do is I'm going to break it up with addition, but I'm going to put a bracket and keep the minus sign because really the whole thing is on the bottom. So the whole thing really is going to be negative. So I'm doing natural log 2 plus natural log x squared because those two are multiplied together. And notice the minus sign in front still applies to both of them because they're both in the denominator of the fraction. One more step, natural log 1 minus. The one step I have left is I have an exponent on that natural log. Exponents always end up in the front. And there you go. That's expanded as far as you can expand it right there. All right, last one, finally. Solve that equation. I'm going to start by multiplying both sides by 3. Which cancels the fraction, so I get x cubed is 27. Now, because it's x cubed, I'm going to take the cube root of each side. which is x. The cube root of 27 is 3, and that's it. Hope that helped. Watch this. I'll have it to where you can skip around as much as you need to. Watch each problem as much as you need to. And I'll be here in the morning, during lunch, whatever, B period, to help if you need it. See you tomorrow.